All right, guys, let's get this next session started. Just like the last session, this session is also traffic light white, TLP white. Silence any devices you have before we get started here. The title of this next topic, Attack Flow, Beyond Atomic Behaviors, and our three presenters here, we have Desiree Beck from the MITRE Corporation, and we have Gabriel Bassett, did I say it correctly? Bassett. Gabriel Bassett from Verizon, and Masuoka from, and let me get this whole thing, Fujitsu System Integration Laboratories Limited, Japan. So with that, I'll let you guys take it away.
Thank you.
Thanks, Joshua. So we've been introduced, so I probably won't linger on this slide. But there we are officially, and the slides will be posted at some point, so you'll have our contact information if you needed it. This work was done by the Center for Threat Informed Defense, and we've had actually another talk at the conference. We did a workshop on Sunday, but if you haven't heard of the center, we conduct collaborative research and development projects, and we do it in combination with the best security teams from everywhere. You can see in that circle there. And also then with MITRE, where we've got, technical resources, and MITRE is known for, our objectivity in that. So it's a combination. And we've got about 30 organizations involved, and we'll soon be publishing our 18th project. And what's really neat about the center is that when the work is complete on whatever project, it is publicly released. And so it's available for the whole community. And the Attack Flow project was released in March. And so we have, at the end, we'll give you the links to that. We've got the GitHub site, blog posts and things, which we could refer you to. And then there's actually a follow-on project underway. We called it Attack Flow 2, which wasn't too original, but it works. And we'll be finishing up probably end of summer, and it'll be published at probably, we're thinking October, but in the fall in any case. So members actually choose, so of all the 30 members, they choose then what projects they want to support. And Attack Flow is actually very popular. We had 10 industry partners supporting it and 2 nonprofits. And they don't only provide the financial support, to do the work, they also are very active, and they contribute technical expertise, feedback throughout the project. And, it was very collaborative. We have a MITRE research team that works in conjunction with different representatives from the different companies. And I was the project leader on the Attack Flow project. And then both Gabe and Ryu were directly involved in the hands-on work, so we worked together. And when we saw the theme of the conference this year, Strength Together, it just very much suggested, we should definitely put a proposal in, because that's really the philosophy of the center, is that we're stronger together, and we work collaboratively and then put it out to the community for hopefully follow-on input from them as well, or from you guys. So our presentation has 3 parts: the problem, the solution, and the impact. And we've split it between the 3 of us. So I'll be doing the problem piece, Gabe is going to do the solution piece, and then Ryu will do the impact piece. So to start with the problem, what is the problem? Well, the problem is that defenders tend to track adversary behaviors individually. So you may have seen reports where you've got the table maybe of attack techniques that come out, or a list of techniques. And in doing that, it's good. I mean, it's a good start. But adversaries actually think in terms of sequences of those techniques. Their attack is comprised of this followed by that and so forth. And we're not necessarily seeing or considering those relationships, which can be a problem. That things like, by not doing that, you may have trouble identifying false positives. So, for example, you may see 2 individual techniques that are out there in whatever information you're looking at, and you think, okay, that's nothing, let's ignore it. But if you knew that they were related and you saw them together as a unit, then it could be like, wow, that's really significant. So that's the kind of things that we're trying to address. When you have campaigns or incidents happening and you don't have a very, as thorough understanding as you can have, your response isn't going to be as good as it could be. So these problems and the idea that we need to really be looking at sequences, that was the idea that motivated the idea of the Attack Flow project. So what is an attack flow? This is a really basic representation, just kind of to get you started. And Gabe is going to go into the details, so you'll know a lot more after he's done. But basically, an attack flow is comprised of 5 things. So you've got the flow itself, And then you have lists or collections of actions, assets, and properties. And then you also have the causal relationships between the actions and assets. And again, Gabe will go into details, but this is, at a very high level, what is an attack flow? That's what it is. And then how do they help? They help with everything from explaining defensive postures to executives, to developing realistic adversary emulation scenarios. And Ryu was actually going to talk more about those use cases, how they're useful, and what their impact has been or could be. This is an example here, the graphical representation. It was a Tesla breach from 2018. And it happened when Tesla's cloud environment was compromised to mine cryptocurrencies. And so if you look up there, you'll see the pink boxes are the actions, the blue boxes are the assets, and then the green boxes are the properties that are assigned, in this case, I think, to the different assets. And then the black lines are the relationships between those actions and assets. And I should point out, if you look at it, I think you could probably see the details. You'll see that in the action piece, we've referenced different attack techniques. But to say that attack flow was developed to support all actions, it doesn't have to be attack. We tend to use the attack, but it could be used, you could also use like Veris or a vendor tool or anything, your organization's own solution. And Gabe is going to probably show you more of the Veris side of things. It's really was purposely defined or developed so that you could use whatever you like there. And now I think we're going to go into the solution, and Gabe will talk about the data format.
So this is the dense portion of the presentation. Des told you about the problem, and so I'm going to tell you how to solve it. And we're going to do this by walking through an example, because that's the way I like to kind of do things. So we're going to start with the scheme, and I do want to thank Mark Davidson, who's now at Tidal, and Andy Applebaum, who both now at Apple, who contributed to building the schema. And the schema is really is what's required, what's optional, what you connect in. It forms the foundation of attack flow. And so the schema is initially in JSON schema, but you can also define it in terms of a graph. And we're going to call that the RDF version because it's linked data. And one of the nice things is the graph version, because it's linked data and RDF data, it kind of inherits a lot of that. And so you can represent it as JSON, as in like JSON LD, as tabular data, or really kind of whatever schemas. And by the way, I do want to talk a little bit about RDF, because if this is the first time you've heard this and you're Googling it and you find it, you're going to get scared and you're never going to come back to it, because it's this weird, really complex, really dense academic thing. And that's all up here. We're using this bit down here. And so at its base level, graphs are just nodes, right, dots and edges between them. And RDF is just three things. It's the node, the edge, and then the node it points to. And in fact, they're defined by URIs, or we can call them URLs, because that's really what they are. And so our three things are all just three of the same thing in a certain order. It's the subject, the predicate, and the object. But that doesn't make sense, right? Like, no one thinks about them in that way. And so it's a lot easier to think about them in terms of the source, the relationship, and the destination, even just the beginning, the middle, and the end. Whatever makes sense to you, we're thinking about just three things in an order, and that's what an RDF triple is and what our graph is built out of. And again, if you go search for this, you're going to see things like OWL for web ontology language, and it's going to say this is a tool you can use to reason across your graph, and you're going to go, I don't need to do that. Why would I want to do that? And you don't in attack flow. You could go do these things, but in reality, you're going to be using RDF or OWL to do things to say, like, this node is the same as this node, right? Asset 1 is the same asset as my firewall. Very simple relationships. And so don't get too scared by what you find when you look at RDF and OWL. Attack flow really is dealing with a very basic portion of it. So back to the example. We have our foundation. Our foundation is the schema, and now we need to build on top of that. And anytime we have three things, actions, assets, and order, we can build a flow. And in the future, I think tools are going to output flow data for you automatically, but right now, this project just came out a few months ago, and so we create them manually. And you can really kind of create them from a lot of different types of data. You can do it from incident reports, from red team reports, threat intel reports. And one important thing here is that attack flow supports both action and asset-centric views. Right, in our IR report, we talk about the servers first, right? It's very asset-centric. And in our red team report, we talk about the action first, right? Phished, installed, things like that. And in general, we see that, right? Because if you get a blue team report, it's gonna have like the firewall and a user and a desktop, and there's gonna be a line that says action 1, action 2, action 3. It's very asset-centric because the assets are the nodes. If you look at like a red team report, a lot of times it's action-centric and says, we did action 1 first, then we did action 2, then action 3, where the actions are really the nodes and the connection between them, the relationship is kind of implicitly the asset connecting them. And so attack flow makes those two views interoperable. And so you've got your data, now you need to structure it. And the tool we're going to use for that in this example is Attack Flow Designer. It's this free tool that was published as part of the Attack Flow 1 project. Credit goes to Michael Corenzo at MITRE who built it. And it's a really good, assuming you can build a node NPM app, it's a really good kind of smooth entry into this. It's not going to build like these big complex things, but when you're at that point, come find any of us, we'll help you solve that. And so here we see the actions are in blue. The assets are in orange, and it goes action, asset, and that's very important. That's how we get that interoperability between kind of the red and blue side. And we have our properties down here in red, and the relationships of the lines. And one thing you'll notice, as Des mentioned, her example uses attack. Here we're using Varus. If you don't know, Varus is the schema that the Verizon team, the DBIR team uses to code incidents and breaches. It's helpful for us in that it's a very good structured way to represent things, but it's just the way we think. And if Des thinks in attack and Ryu thinks in something specific to him, the cool thing about attack flow is we can all have our own schemas, our own namespaces. And so we can use whatever makes sense to us. In fact, I can explain, we'll show later how I can say this is thing in my schema relates to the thing in Des's. And in fact, because we're incorporating namespaces, I don't even have to put that whole thing in. I just have to put, Varus person, and then everything about what a person is implicitly exists in that other namespace. And so this is this great capability associated with attack flow, and it's based on the fact that we use URLs or URIs for the IDs. And so you've built out that tool, you point and clicked and filled in the fields. And one thing I want to point out is that the reason action is longer here is because it has more defined properties. You can add as many properties as you want on each one of these. And so it's not restricted from a property perspective. And so you fill that out and you get a file. It's a JSON schema file. And don't worry about the fact that this is an eye chart. A lot of these charts are that way just to show that you can do this and kind of give an idea. It's not meant for you to figure out what each line says. And so the nice thing here is that action, assets, relationships, data properties, object properties, those are all in their own space. And that's kind of the benefit you get from doing this as a JSON schema. You can also convert it to a graph. This is JSON LD. And so here it's a list, right? And each object in the list is its own node. And the nice thing here is that you can see this kind of key value property where here's the key and here's the value. And so what you have is you have a source, a relationship, and a destination. You have your triples, and you have all the triples coming from that node all together. The other nice thing is because this is RDF data, you inherit that ecosystem. So here we're expressing it as JSON. You can also express it as tabular data. You can express it as XML. Really, there's a format for almost anything. There's human readable formats. And because there's so many formats, it's very storage agnostic. You can store it in SQL databases. You can store it in NoSQL databases, key value stores, graph databases, flat files, whatever works for you. And you also get kind of the tooling ecosystem, which includes APIs for transport, includes visualization, editing tools, reasoning tools, programming, querying. There's already this big ecosystem around linked data that you get to take advantage of from a graph perspective. And so, but this is all text, right? We don't want to work in text. We want to look at something. And so what's it look like? This is us having converted it. We built it in Designer. We converted it to a graph, and now we're looking at it in a tool called OntoText GraphDB, just because it's this nice free graph database. There's a lot of tools you could use. And again, here, the actions are circled in blue, the assets are in orange, and you still have this causal path. And by the way, here we're using actions to mean malicious actions, but it doesn't force that on you. You could use actions to describe legitimate actions of your system. You could use actions to describe responses you would take. And so, like, you know, if you have SBOM data and you say that this piece of software, it relies on this other piece of software, you can build relationships in that way to say a compromise of this piece of software would create an action that compromises something else. And so you can describe that kind of resiliency or lack thereof. And so those are the actions and assets. We have the properties down below in this orange box, and I've only shown kind of the bigger ones, not like the timestamps and such. And so those are 3 of the parts that Des showed you. The 4th is the flow, and so we define a single flow as a node, and then our relationships are all these edges in between, right? And the nice thing in the power of attack flow is it describes the 3 C's. It describes causality, it describes context, and it describes complexity. And so causality, obviously, is the causal path in the middle, the stuff that happened. And again, right, you've got actions, you've got assets, you've got order, you can build that causal path. Second, it describes context, and so log files. If you have information about the asset, you can build that in. If you have the attack knowledge base as a graph, you can reference into it and take advantage of all that additional context and all those properties. And we have complexity. And this one's a little harder to explain. From a graph perspective, and we put a lot of work into kind of the theoretical behind this, behind attack flow. In graph terms, the action and assets create a bipartite network, which is one way of representing hypergraphs with complex relationships. And who here cares about that? Yeah, no one, right? Like, this is the kind of thing from theoretically that we care about. What benefits y'all is, I'm from southern US, so I say y'all a lot. What benefits y'all is that the complexity allows for the asset-centric and action-centric views to work together and interoperate, and that is very important for the community. It also allows for complex incidents to work. And so where we have fan-out, we have collapsing back down, we have going back to previous assets. Attack flow works for simple incidents, but it also works for complex ones. And so, but I mean, this is all cool, you get to look at and stuff, but really what you want to do is you want to ask your data questions. I'm a data scientist, I want to ask questions. I don't want to look at data because I've got lots and lots of it. I want to aggregate it and analyze it. And so we can do that. Here, because we're doing it in a graph database, we're asking questions in Sparkle. But you can really do it in any language that your data store supports. On the left, we're asking it, what assets have been breached? Very simple. On the right, we're asking it, what actions have we seen? And these are very simple queries, but you could go back and conceptually you could say, hey, show me everything within a time span. Or count what actions happen most often, because that's what I want to go then target when I go and buy my mitigations. You can really kind of query it to the extent that your query language supplies, whether it's SQL or Cypher or KQL or whatever. And so, and again, right, this isn't just Varus. We're using various actions here, but it could just as easily be an attack. And in fact, you can map between them, right? There's a CTID project called Attack to Varus. And that would let you map from attack to Varus in the same namespace. You could define in either one of them and still know what was happening in the other by bringing in this project as an additional namespace. And so with that, I'm going to hand it over to Ryu, someone that I learn impressive stuff about every single day. He's going to tell you about the benefits of attack flow.
Okay, let me talk about impacts and use cases of attack flows. These are what we compiled at the beginning of this attack flow project, and they are yet to be realized, but we believe they are important and valid, okay? And we categorize them in several categories. The first one is better communication. this is about human to human. This is mostly about visualization of attack flows. For example, we can use some of the visualization you have seen in the previous slides for visualize IR, incident response, or threat intelligence, or red team data. We believe some of the attack flows we might want to simplify to visualize. So we are thinking of aggregating nodes and actions and filter tangential properties to give out a simpler version of attack flow visualization. And the one more important probably is to use visualization to explain defensive postures to your executives. And this one is too small, so we have a blow-up one in the next slide. And so what we did in this visualization is we overlaid money flow on top of attack flow. And this is one of our attempts to visualize in many ways, because it is in machine readable format. You can have a lot of visualization you might want to try out. And we are also working on different visualizations in the follow-up project. Okay. And the second one is a better intelligence exchange. Actually, this is about machine computer to computer communication. And so the future I foresee is that attack flow sightings are shared machine to machine accurately and at machine speed. So and it doesn't always have to be a full attack flow. Here we have a graph pattern. This is something that a part of attack flow that occurs again and again. So we sometimes call it motif. So we can also share full attack flows or a part of attack flows which are graph patterns and motif. Okay. The next category of use cases is better operations, and we believe attack flows contribute to better operations. And the key, we believe, is the attack flow queries Gabe mentioned. And so my example is that I had one technique which was very difficult to mitigate in the past. At that time, what I thought was that, but technique does not happen in isolation. So there are attack flows going into that technique and then coming out of that technique. So even if you cannot stop a particular technique, if you can stop before the technique or immediately after the technique, then we are much better positioned, safer. So that's better operations and a better defensive planning. So if you go backward, if you follow the attack flows backward, then you should have a much better understanding of attack surfaces. We can use them analyze risks and aggregate attack flows. And then as Des quickly mentioned, but we can build and communicate non-atomic detections. So we can combine a detection of multiple technique in attack flow, then we should be able to have a much more reliable detection of the attack. Choke points here is what most of the attack flows go through, techniques that most of attack flows go through. If we can identify these choke points, then we should be able to invest our resources much more efficiently to deal with those choke points. And then better assessment. So we can use attack flows to build more realistic adversary emulation scenarios for pen testing, or to automate breach and attack simulation tools, or BAS tools. When you do that, probably logic operators like and or for the attack flow schema is the key, we believe. So in order to realize those use cases and merits or impacts, we believe it is critical to have a lot of attack flows. So we started to build a corpus of attack flows. And currently, we have those 6 of them, one of which, this one, is provided from outside of the project, sorry. So you can find them in our GitHub, in the GitHub here. And so we are planning to build more, create more attack flows. And we invite you to provide attack flows. So that's it for me and Des.
All right, so we have a number of resources available, so we hope that you'll check them out and even become an early user of attack flow. So that would be fantastic. You know, you may be a vendor that could implement attack flows in your tool or service, or maybe you're an organization and you could start to integrate attack flows into your processes and that. So, and it can be hard, you know, using attack flows isn't immediately easy. You know, we had the workshop, and even as a team, you know, that's part of what we're doing. You know, we're building out actually for attack flow 2. We are making a much bigger corpus and learning things along the way. So it isn't necessarily easy, but we are here to help, and we'd love to help you guys. So contact us directly, or, you know, we've got the GitHub. If you've got feedback there, that would be great if you contributed at that. I think the workshop material, not the workshop itself, but we're thinking about maybe putting some of the resources like that online too at some point. And we've also got, so here's the, on Medium, there's a blog post, and that might be a good place to start. It kind of reviews what we've seen today, but kind of a higher level overview of things. And then you could go to the GitHub site for the details and actually to look at the schema and that corpus, and that's all on the public site right now. So, you know, we are refining the solution in attack flow 2, and part of that is based upon, you know, community feedback. So anything, any comments that you guys have, any suggestions, if you could open them as an issue in GitHub, that would probably be the most helpful to us. Or again, contact us directly. We are getting some community feedback now if you go to GitHub and have a look to see what people are talking about. So that again, you know, the whole community coming together is going to make it the most successful.
So for the DBIR, data breach investigations part from Verizon, like we spend a lot of time coding data, and we spend a lot of time teaching people to code data. And so it's very likely that as you come in, you'll want to look for that. We're going to start trying to produce some content to help teach people how to code this. But also the same way for the DBIR, by the way. We are always looking on the DBIR for new contributors, people that can help bring incidents from their industry, from their region in the world. And it helps make our report more applicable as well. And so if you have incidents that you might be willing to contribute for the DBIR, they go back for the good of the community. Also, if you want to figure out how to code incidents, whether in attack flow or in Varus or whatever, to structure your incident data, again, reach out. we're here to help, and we've done it many times before, and we love doing it to help other people figure out how to structure their incident data. And so with that, I open it up to questions.
Thank you.
Thank you.
Thanks for your talk. Eric Julian from Okta. Just real quick, so do you have any, I guess, proof of concept for how to actually use it for detection, like whether in Splunk or Elasticsearch or anything like that?
And so part of the second project is to look at workflows. And so the first project produced a schema. And the second project is looking to then produce like documents to help explain how to accomplish the different things you can accomplish with it. I don't remember if searches within like Splunk or such are one of the workflows for, but hopefully out of the second project we'll have some discrete workflows to say this is how you would automate a pen test, or this is how you would do detection or such. But in general, detection gets to be one of the really interesting things because the challenges will not be with attack flow. They'll be with how you store the data, because if you pump in lots and lots of data into a graph, it gets very big very quick. And so if you're searching for, every time you pump something new and you're searching the entire graph for a specific, say, pair of nodes, which is very easy to do, right? You can, if you were to say, hey, I want to find A that leads to B that leads to C, you know, that's a simple query in almost any language that you'd be doing it in. But if you have to do it every time you get something new in over the entire data set, it's going to be very slow. And so the bigger problem ends up being your optimization of how you execute and when you execute the searches versus the actual querying. The queries end up being rather simple to write.
Yeah, and then just as I was thinking about something along those lines of like, I mean, if you got a 20-step flow, I don't know if it would, I don't know, I guess optimizing it is, you know, 4 of those steps optimal or 3 of those steps to get closer to
and so
the actual flow.
If I were doing it, I would put the entire flows in, because that aggregate data, particularly when you go, like Ree was talking about, when you go and do strategic planning, you might find out that 20 flow or 20-step breach, and every other one of your breaches all go through this one node. And if you left out that portion when you were coding it into your data set, you might not find that out. But when it comes to searching, I think you use the minimal search that's viable. In fact, so like Grapple, GRPL is this company that does graph-based detections in memory. And like there's some of their matches, or many of their matches, I think are just like 2 nodes, or effectively 2 actions, you know, an action, an asset, and then an action. And they still get a huge amount of benefit about that, because every new thing you put in there does a better job compared to what we are doing, which is looking for 1 action. Even just stepping up to 2 actions clears out a lot of the chaff and false positives and focuses in more narrowly. And so I do think that you use the minimal matching you need. Talking about motifs or graph patterns, right? Even in academia, trying to match a pattern past like 5 or 6 nodes, and granted they're doing it in a much more generic way, but it's very computationally intensive. And so the smaller you can make that match, the more efficient, the better it's going to be. But that gets back to the efficiency question.
Okay, great, thanks.
Yep.
We have about a minute left if there's any other questions. But... All right, well, thank you so much for coming to see our talk today.
Thank you.
Hope you enjoy the rest of the conference.